Hello, Mr. Geiselart here, and we're going to take a look at the Gopher 5 lottery game. All of the lottery games are basically done the same when we approach these problems in that you have a certain probability of winning a certain prize. So the first thing we want to do is find the expected value of the Gopher 5, and we want to change the jackpot amount a little bit to see how that affects the expected value. In the first example we're going to look at a $100,000 jackpot. So to do that, I'm going to start off by finding the expected value. The expected value is the prize times the probability of winning that prize. So in the first one, it'll be $1 times the probability of winning $1, which is 1 over 13, plus the prize of $15 times the probability of winning that, which will be 15 times 1 over 178, plus the probability of winning that part is $500 times the probability, which is 1 over 7,304, and then plus we have the jackpot times the probability of winning that jackpot, which is going to be 1 over 1,533,939. So what I'm going to do first is I'm going to add up all of the expected values except for the jackpot. And when I do that in my calculator, I'm going to end up with 0.22964838. And you want to go out several decimal places, otherwise when you get to the bottom answer, you won't be correct because you're multiplying by really big numbers. So if you round early, you're changing the value, and then when you multiply by really big numbers, it makes the error really big. So I just added up all of the expected values for all of them except the jackpot, all the prizes except the jackpot. So now to this, I'm going to add in the jackpot. So the jackpot is 100,000 in the first one times 1 over 1,533,939. And when you put all that in your calculator, you'll end up with 0.29 something. And these you can round to 2 decimal places, the nearest penny. So now if I want to find the expected value when the jackpot is 950,000, again, I'm going to start with the expected value of all of the prizes except the jackpot and just add that in. So that's 950,000 times 1 over 1,533,939. And when you put that in your calculator, you'll end up with 0.77. And then you'd do the same thing for 4 million. You would just put 4 million in that spot there, and that's how you would get that. Now, the last part is, how much would the jackpot have to be to make this a fair game? Well, to do that, what we're going to do is, again, we're going to start off with the expected value of all of the prizes except the jackpot, plus the jackpot. Now, I don't know what it is. That's what I'm looking for, so that's X times 1 over 1,533,939. And that has to equal 1. The reason why it equals 1 is because it costs $1 to buy a ticket. So when the expected value is equal to the cost of playing, that means it's a fair game. So now all I have to do is solve this for X. So we start by subtracting 0.22964838, subtract 0.22964838, and you get X times 1 over 1,533,939 is equal to 0.77035. Now what I'm going to do is I have to multiply by the reciprocal. So if I want to get rid of this fraction here, I multiply it by the reciprocal of that. So it's going to look something like this. 1,533,939 over 1, and multiply this by 1,533,939 over 1. When I do that, this cancels with this cancels with this, and leaves me with just X equals. And then when I multiply that out there, I end up with 1181672.39. So $1,181,672.39. That means when the jackpot is that, the expected value will be 1.